All right, in this lesson we will continue our exploration of transformations of exponential functions. In other words, if we look at a parent function like 3 to the x power, what happens when we subtract something from the end? What happens when we add something in the exponent? We're going to find out in this lesson. You really should be doing this lesson without a calculator. So, no calculators, please. Problem number 1. Let's see. Let's make a quick table of values. We are supposed to make 2 graphs at a time. First, we're supposed to graph just the parent function, which in this case would be basically y equals 3 to the x power. That would be the parent function. Hold on, let me zoom in. And then we will do the minus 5 to it. So, if we look at a quick table of values for this, okay, so here we go, x's and y's. So, like -2, -3, whoops, sorry. Let me try that again. -2, -1, 0, 1, and 2. I'm just going to use those for my parent functions. Okay, doing 3 to the x power, all right. So this would be, maybe I didn't leave myself enough space. So this would be 3 to the -2 power, right? So that's going to be 1 over 9. And this would be 3 to the -1 power, which would be 1/3. And this would be 3 to the 0 power, which is 1. 3 to the 1 power is 3. And 3 to the 2nd power is 9. So let's graph this up and see what we have. So remember, this is the parent function. So at -2, we're at 1/9, which is virtually on the line. At -1, we're at 1/3, which is up a little bit. At 0, we're at 1. At 1, we're at 3. And at 2, we're at 9. Okay, so I'm seeing the asymptote would be the x-axis. So don't forget to show the asymptote as a dotted line. Okay, and so if I just go ahead and draw the curve, it would be like this. Okay, so there's the parent function. Now, as we learned in our exploration in class today, if you subtract something on the end like this, this will cause the transformation. This will cause a shift down 5. Okay, this -5 is just going to cause everything to shift down by 5. All right. So, you know what, I might just cheat a little bit if I can get away with it. Let's see if I can do this. Alright, a little cut and paste maybe. So, I'm going to take these same values, but I'm going to shift them down 5. So far, here I am down 1. This is too slow. Because I shifted down 2, let me speed this up. Down 3, down 4, and down 5. Okay, so that's what this graph would look like if I shifted everything down 5. I'll go ahead and color this a different color. I'll do green. So this is the actual function, not the parent function, but the actual function that we were asked for. All right, and then we go from there. Okay, so you can always get a graph by first graphing the parent function and then doing whatever transformations you have, in this case shifting down by 5. So now let's go ahead and answer the little questions we're supposed to answer. This, we're supposed to say if it's increasing or decreasing, domain and range. All right, so this is, of course, increasing. So let's just put that on here. Increasing, right? The domain, I'll just put D for domain. The domain is negative infinity to positive infinity. The range, bottom to top. The bottom of this graph is down here at -5. Hold on, did I mess up? No. Yeah, so the domain is down here at -5. So the range starts at the asymptote of -5. So the range will be -5 to infinity because it goes from the asymptote up, bottom to top. Speaking of asymptote, the asymptote it was shifted down 5. So instead of being the x-axis, it'll be the line y equals -5. So there's the asymptote. What else? So increasing, whoa, why did I put a D on that? Increasing. Okay, increasing. What else? Increasing, decreasing, domain, range, and the asymptote. I guess that's it. So that's it for problem number 1. Kabam. So we will do the same type of thing for all of these problems. So let's do problem number 2. First, let's make our little table of values. Okay, so x and y. So once again, I will do my -2, -1, 0, 1, and 2. All right, I think I made that too big. Okay. Now first we will graph the parent function, and the parent function is y equals 1/2 to the x power. All right, so this will be the parent function, and then we will do the +6 thing. So if I do, you know what, I better make my pen a little smaller. Maybe even zoom in a little closer. Okay, so I'm doing 1/2 to all of these powers for my parent function. So look guys, if I do 1/2 to the -2 power, that's going to be the same thing as 2 squared, which is 4. Remember, if you do a fraction to a negative power, you just do the reciprocal and make it a positive power. All right? So similarly, if I do 1/2 to the -1 power, I just do the reciprocal, and I get 2 to the 1 power, which of course is 2. All right, 1/2 to the 0 power, anything to the 0 power is 1. If I do 1/2 to the 1 power, well, that's just 1/2. And if I do 1/2 squared, well, 1 squared is 1 and 2 squared is 4. So this will just be 1/4. So let's graph this, what we have so far. So I have at -2, we are at 4. Okay, at -1, we're at 2. At 0, we're at 1. At 1, we're at 1/2, that's right in the middle. And at 2, we're at 1/4, which is right about here. Okay, so clearly this graph is decreasing. Let's go ahead and draw the curve as best we can. Oh, the asymptote. Of course, the asymptote is starting out here at the x-axis. All right, always draw the asymptote as a dotted line. So the function starts out, the parent function, looks like this. Now I'm going to temporarily take the curve back out so I can see the dots where the graph came from, because remember, this is the parent function. Now, to graph this actual function, including the plus 6, I need to take this and shift it to the left by 6, all right, because that's what this plus 6 does. So what I could do is just take each one of these points and move them to the left by 6. So here we go. 1, 2, 3, 4, 5, 6. All right, so I just slid all of these points to the left 6. So these values show me where the actual curve will be. And that's going to look very much like this. So let's give it all the information we're supposed to give it. This is still decreasing. Alright, so what all do we need here? I forget. We need domain, range, and asymptote. Okay, so the domain is still going to be negative infinity to positive infinity. The range, well, it goes from the asymptote up. So the range will be 0 to infinity. And speaking of the asymptote is going to be y equals 0. Alright, that's it for number 2. Let's take a look at number 3. Alright, so we have this function. Let's look at the parent function and graph that first. So the parent function would be like this. F of x equals 2 to the x power. Alright, this will be the parent function. And so let's make a quick table of values for this parent function. Okay, x and y. So once again, I'm going to use -2, -1, 0, 1, and 2. And we're just doing 2 to the x power. So if I do 2 to the -2 power, because that's x, then that's going to give me 1 over 2 squared, which is 1 over 4. If I do 2 to the -1 power, that's going to be 1/2. If I do 2 to the 0 power, well, anything to the 0 power is 1. 2 to the 1 power is 2. And 2 to the 2nd power is 4. Did I already do that? No. Okay. So this is the parent function y equals 2 to the x power. Okay, so let's go ahead and graph this parent function. So at -2, we're at 1/4, so that would be halfway, so this would be about 1/4. At -1, I'm up to 1/2, so that's dead center. At 0, I'm up to 1. At 1, I'm up to 2. And at 2, I'm up to 4. 3, 4. Okay, so there you go. The asymptote would be right about, hold on. For the parent function, the asymptote is always going to be here at 0. And we'll see what happens with the actual function. Now, take a look at this. Of course, you can see that the curve is going to be right through here. But before I draw it in, I'm going to go ahead and do the transformation to find the other stuff. So, look at the two transformations that we have. I've got this -3 in the exponent, and then I've got this -1. What do these do? Well, when you're adding and subtracting in the exponent, that's always a left or right motion. And it's always the opposite of what you might think. So -3, subtracting 3, will actually be a shift to the right by 3. And having this minus 1 on the end like this, a number added or subtracted on the end is a shift up or down. And it works just like you would think. A negative 1 will be a shift down 1. Okay? So compared to the parent function, this function, function c, would be to the right 3 and down 1 from there. So that means I should be able to take each one of these points and move them to the right 3 and down 1. Okay, so here we are at the original location. I'm just going to move these to the right 3. So 1, 2, 3, and then down 1. Okay, so here. Alright, so you see all these points. If you look at one at a time, each one is right 3 down 1, right 3 down 1 from where they were. So this should be where the new function is. Now, pay careful attention to the new asymptote. Okay, we went right 3 and down 1. If I moved the asymptote right 3 and down 1, well, moving a horizontal line right 3 doesn't really mean anything. Because it already goes left and right forever. But moving it down 1, sorry, I got a frog in my throat. Ribbit. Moving it down 1 would look like this, though. And you can see it, right? You see the graph, whereas it used to approach 0, now it is approaching -1, so it just makes good common sense. So there is the new asymptote. Alright, so now we'll go ahead and draw them both. So here's the original parent function, which would have looked like this. Wow, let me try that again. I've got a little too much friction going on over here. I need this to be a little more slippery for me. Okay, you know what? I'm going to do this off camera. Yeah, nailed it. I could feel you guys beginning to laugh at me. Alright, so there's your parent function, but of course the green function is the real function that we were supposed to graph, function c. In both cases, they are, how you say, increasing. And the domain, once again, is -infinity to +infinity. The range is going to go from the asymptote up. So the range will be -1 to infinity. And the asymptote is, of course, y equals -1. Please do not forget the y equals. You will lose half credit if you don't put y equals. Increasing, what am I, country now? I guess this is Georgia. But I meant to say increasing, because I'm a Yankee. Alright, let's move on. Get a little racial up in her. Okay, number 4. Once again, let's rock this parent function. Let me make sure I haven't already done this, though. I see that. Okay, 1/2. And, okay, I guess once I've done this parent function, then I can start copying off myself. So one more time with my parent function, though. So I'm about to make a table of values for the parent function, which would be like y equals 1/3 to the x power. That would be the parent function before these transformations happen. So one more time, here comes my table of values. Okay, x, y. And one more time, I will use -2, -1, 0, 1, and 2. Okay, if I do 1/3 to the -2 power, of course, that would be the same as having 3, because I do the reciprocal, squared, which is 9. All right. Similarly, if I do 1/3 to the negative 1 power, that would be like 3 to the 1 power, which is just 3. Reciprocal. Make it positive. If I do anything to the 0 power, I get 1, so that's cool. If I do 1/3 to the 1 power, that's just 1/3. All right, all right, all right. So if I do 1/3 squared, well, 1 squared is 1, and 3 squared is 9. Kabam. So these are the values that I must graph for my parent function, my friend. So negative 2 is at 9, so kabam. Negative 1 is at 3. 0 is at 1. 1 is at 1/3. Should worry about her. And 2 is at 1/9, which is basically on the line. Not quite, but super close. Alright, so we've got these points, and obviously the asymptote would be right here. But let's go ahead and talk about the transformations that are about to happen. Once again, we got these two transformations. This x minus 2. What is this minus 2 going to do? Remember, in the exponent, this is left-right motion, and it is the opposite of what you would normally think. So minus 2 up here is going to send you to the right by 2. Now, a number on the very end like this is up-down motion, and it works normal, like you would normally think. So minus 6 is in fact down 6. Okay, so this is left-right, this is up-down, this is opposite of normal, and this is normal. Okay, so to get the function d here, I need to take my parent function and move it to the right 2 and down 6. Right 2, down 6. Now I am going to cheat a little bit by cutting and pasting. Technology, gotta love it. So I said we have to go to the right 2 and down 6. So here we go. So 1, 2 to the right, and 1, 2, 3, 4, 5, 6 down. Yeah. Okay. Yeah. Whew, for a second I thought I lost all my points. Yeah. So they're down here. So this is what it looks like when you move everything to the right 2 and down 6. Okay. So there you go. Let's talk asymptotes. The asymptote of the parent function is, of course, 0, like always. Okay. Now, when we went right 2 and down 6, moving right 2 didn't do anything to the asymptote. A horizontal line goes forever in both directions, so moving it to the right, it's still the same line. But moving down 6, that's new. So 1, 2, 3, 4, 5, 6. So of course the asymptote should be here at negative 6. And that's why we did learn early on that this is why you can tell what the asymptote will be just by looking at this number at the end. Because the number at the end tells you how far you moved up or down. So if it's negative 6, of course, it's going to start off from 0, like normal, and just move down 6, which puts it right at negative 6. No problem. So there will be our new asymptote. Now we just got to draw the curves, which I will do off camera so you guys won't see me fail repeatedly. So there's your parent function. Please understand that even though it looks like I'm touching the asymptote, in our minds we know we're at 1/9, 1/27. It's not actually touching. But now let me go ahead and just draw the actual function in green. All right, and there it is. So this is still decreasing. Wait, did I say still? I shouldn't have said still. These graphs were increasing. Okay, increasing. This graph, when we did number 2, was decreasing. All right. Remember, we might as well go ahead and focus on this. If the base is less than 1, it's going to be decreasing, as you can see. If the base is bigger than 1, excuse me, it's going to be increasing like this. So you see the pattern? All right. So this base of 2, that's bigger than 1, increasing. So as soon as we saw that this base here was less than 1, we knew it was going to be decreasing. All right, and both versions are decreasing. So let's see. So the domain is negative infinity to positive infinity. The range, all right, well, that's the asymptote on up. So that's why the range is -6 to positive infinity. And the asymptote itself is y equals -6. Do not forget your y equals. Okay, so that was number whatever this is. 4. All right, I think I'm going to have to zoom out. Number 5, describe all the transformations performed on problem number 3 above. Okay, well, we kind of wrote them on problem number 3. We shifted right 3 and down 1. So we can just list that again. All right, right 3, down 1. Boom. Okay, number 6. Number 6 is a little bit of a trick, so watch it. Do not get fooled. The negative x power. Remember what we've been doing anytime we have a negative power? What I've been telling you is to do the reciprocal and make it positive. So really, before you even begin this problem, you should do that. So f of x is really this. The reciprocal of 2 is 1/2. And once you do the reciprocal, you can go ahead and make it a positive x. Okay, plus 1. So this is the graph that we are really graphing. You can forget about what's written here and just do this. So anytime you see a negative x up here, do this. Reciprocal, make it positive. So there's that. Now, so the parent function that we're going to be dealing with is the 1/2 to the x power. Okay, so like y equals 1/2 to the x power. That'll be the actual parent function. Now I've already graphed that parent function, so I think I'm just going to cut and paste that. Alright, so here's my table of values, just like we did before. Alright, so these are my guide points where I just graphed from the parent function. Now, so let's talk about the transformations we're about to do. There's really just the one transformation. This plus 1 right here, what's that going to do? That is going to shift our graph up 1 unit. That's the only transformation. So we're just going to take all of these and shift them up 1 unit. And here's what they would look like shifted up 1 unit. Alright, so let's just draw these curves and the asymptotes. There's your parent function. And there in green is your actual function. I might have made it slightly too low. It's a little better. Anyway, The fact is, this is decreasing. And so you might not have been able to tell by looking at this version of the function, because that looks like it's bigger than 1, but really it's 1/2. So that's why it's decreasing. And of course the domain is negative infinity to positive infinity. The range, alright, goes from the asymptote up, so that's 1 to infinity. And the asymptote itself is y equals 1. Do not forget your y equals. So that's number 6. Let's do number 7. Now number 7 has a parent function of y equals 3 to the x power. Alright, so once again, here is the parent function y equals 3 to the x power. This is how we calculated the values. I graphed those values with the asymptote. The transformation, though, there's only one transformation. It's this minus 5 business. What is this minus 5 going to do, people? Well, hopefully you said this is going to move us to the right by 5. When you're adding and subtracting in the exponent, that's always going to be a left-right motion. And it's kind of the opposite of what you would think. So minus 5 will actually be a shift to the right 5. Okay, so all I need to do is take these values and shift them to the right by 5. And there you go. So these green dots will be my guide for when I draw the actual function 3 to the x minus 5 power. So let me just go ahead and draw these in. Alright, so there's your original function, and there is, there's the parent function, and this is your actual function after we move it to the right by 5. Okay, as far as the information that we're always supposed to give, both of these are increasing, which we knew because the base was bigger than 1. So increasing. Alright, we're looking at the green graph here. The domain, negative infinity to positive infinity. The range, 0 to infinity, bottom up. Okay, so 0 to infinity. The asymptote is y equals 0. We slid this thing to the right, but the asymptote did not move. So there's number 7. Alright, for number 8, once again the parent function is 2 to the x power if you ignore the transformations that are about to happen. So I just cut and pasted this from a previous problem where we already did this. And here is the graph of the parent function. So once again, let's go ahead and do the transformations. And they are these. I've got this minus 1 happening. What's that going to do? Say it out loud. This is going to move you to the right by 1 unit. Alright, adding or subtracting in the exponent moves you to the left or right, but it's the opposite of what you would normally think. So negative 1 is right 1. What is this plus 2 going to do? That is going to move you up 2. Alright, adding or subtracting at the end is going to move you up or down. And it works like you would normally think. Positive is up, negative would be down. Okay, so we need to go, we need to take this parent function and move everything right 1 and up 2. So let's do that. Alright, so here we are. So we have to move right 1 and up 1, 2. So that would put us right there. Okay, so that's it. Now as far as the asymptote, the original asymptote was at 0, so if I move it up 2, then it'll be here. Alright, of course we knew that, we know that whatever this number is, that's where the asymptote's going to be, but it's good to see sort of why that is. Alright, so let's just draw the curves. So there's the parent function. So there you go. The green function is the real function. So one more time, what do we need here? This is clearly increasing, which we knew because the base is bigger than 1. Increasing. Alright, the domain. Negative infinity to positive infinity. The range. The range will go from the asymptote on up. So the range is going to be 2 to infinity. And the asymptote is going to be y equals 2. Do not forget your equals. Number 9. Once again, the same parent function, 2 to the x power. So brit, brat. There's your parent function. Let's talk transformations. In this case, you see the plus 3. What's that going to do? Well, that's going to send us to the left 3. Alright, what about this minus 5? That's going to send the graph down 5. Get it? Alright, so we just need to take this thing and move it left 3, down 5. Let's do it. Alright, so here we go. Alright, left 3 and down 5. So 1, 2, 3. That's left 3. And 1, 2, 3, 4, 5. That is down 5. Okay, so there you go. Left 3, down 5 puts the graph here. And obviously the asymptote will also be down 5 with that shift, so it's going to be right about here. So all we have to do now is draw those curves. So there's your parent function, and there's your transformation. Okay, we are on number 9. If anybody's watching this, trying to watch this video. This graph is decreasing. The domain is negative infinity to positive infinity. The range goes from the asymptote up. So the range is going to be from negative 5. Let's make sure I counted right. So negative 5 to infinity. Alright, negative 5 to infinity will be my range. And of course, the actual asymptote was y equals negative 5. Do not forget your y equals. You will lose points if you don't have it. So that was number 9. Alright, for number 10, we are supposed to describe the transformation that would occur to map the graph of h of x to j of x. So we're referring to the function in problem number 8 and the function in problem number 9, because that's h and j. Now, keep in mind that in problem number 8, function h, to get this function, we had to go right 1 and up 2 from the parent function. But function j, we went left 3 and down 5. Okay, so here's what I think will be the easiest thing for you to do. Let's keep our eye on one point at a time and see what the difference is. All right, here's what I mean. All right, look at function h from problem number 8. Let's track the y-intercept of the parent function. All right, the point that started out at 0, 1. Let's keep our eye on this point and watch where it goes. Now, for function h, we had to go right 1 and up 2. So this point went right 1 and up 2. So that point is now right here, okay, at the point 1, 3. There it is. Now, let's do the same thing and see what happened in problem number 9, function j. Now, again, here's that y-intercept point. Now, for this function, to get function j, we had to go left 3 and down 5. So this point right here went left 3 and down 5. Bam. So that point is right here. Okay? So for function h, this point is right here at, what do we say, at 1, 3. Okay? Now, in function j, that same point is right here at -3, -4. Okay? Let's see. It will be easier to see if I put these on the same graph. So let me come over here, and so this point from function h is at 1, 3. So let me just copy it over. So 1, 3 would be right here. So this is the function h point, okay, while this is the function j point. Okay, alright, because this is function j where we are, and this one I just copied over from this problem over here. So it was right there at 1, 3. We just copied it over 1, 3. So this is the point that we're talking about. Now, so we're supposed to figure out how we would get from h to j. So now that I have these two key points on the same graph, I can start to ask myself how I would get from h to j. Well, I would have to go left and down to get to j, from h to j. So I'd have to go left 1, 2, 3, 4, and down 1, 2, 3, 4, 5, 6, 7. So I'd have to go left 4 and down 7. Alright, so that is the transformation that would do it. So just write that down. Alright, left 4, down 7. Alright, so I think the easiest thing to do is pick one key point and do the two transformations and then see how far they are apart. Alright, last but not least, number 11. We're supposed to create an exponential function k that is decreasing and has a range from -5 to infinity. So the idea is this. Imagine that we have some kind of a graph happening. Alright, 1, 2, 3, 4, 5. We're looking for something that would have an if the range has got to be from -5 to infinity, that means the asymptote must be down here at -5, yes? Alright, so the asymptote must be down here. And it's supposed to be decreasing, which means this type of a deal. Alright, it's doing one of these numbers. Okay, decreasing. Now we know if it's going to be decreasing, that means the base has to be less than 1. Okay, the base has to be less than 1 if it's going to be decreasing. Like I just said, if the asymptote is going to, the asymptote has to be at -5 if the range is going to go from -5 to infinity. So, you know, asymptote. Okay, so I just need to make up an equation that satisfies both of these criteria. So here I go. K of x equals, I just need anything with a base that's less than 1. For example, 1/4. Okay. Now you make your own. Don't copy off of me, people. If I see everyone have exactly what I have, if I see 1/4 to the x power, and then I'm going to have -5. Okay, so that would give me the asymptote at -5. So bam, this would do it. But it wouldn't have to be 1/4. It could be anything less than 1. So in fact, just to make a point, I'm going to pick a stranger number. Let's see. Let's go with 3/8. 3/8 is definitely less than 1. So that would do it. But no one's going to just happen to pick 3/8. So be warned, if I see anybody copy down 3/8 to the x power and then the -5, everyone's going to have the -5. But anyone I see with a 3/8, I'm going to know that you are a copier and a cheat. And you just copy off of the answer. I'm also going to know you didn't watch this video. Alright? Because if you did, you would listen to me telling you not to copy, and you wouldn't do it. So, consider yourself caught, all you people that aren't watching this video and are just copying answers off the answer sheet. From now on, I'm going to know who you are. So be prepared to be ashamed. In the meantime, all of you good people who are watching the video, I love you. Good job. I won't see any nasty 3/8 on your paper. You're my good kids. You know you're always my favorite. Don't tell those other bad kids, because you're my favorite. And with that, I will see you on the next video.